discuss the chapter Aldehyde, Ketones and Carboxylic acid. As you can see, this is notes of this chapter and this. So let's start. Okay, now first of all the introduction part. See, first of all, aldehydes, ketones and carboxylic acid, all of them, you see, are represented like this. This is the structure of ketone, that is CHO. Sorry, this is aldehyde. Ketone is C double bond O, and aldehyde is CHO. And see, this is aldehyde and this is ketone. What happens is that in this, the carbon is the center of nucleophilic attack. What do you mean by nucleophilic attack? That is, nucleophile is the one which has only positive charge and attacks negative charge. So nucleophiles always come and attack this carbon. When it loses electrons, this becomes negative and the carbon becomes positive. So in all the chapters which were there, haloalkanes, haloarenes, alcohol, phenol ether and amines, all the chapters were dealing with electrophilic or substitution reaction, but this chapter is special because it deals with nucleophilic addition reaction, so be prepared. Now let us start the chapter aldehyde, ketones and carboxylic acid. First of all, you need to know the common name of some compounds. This is R C double bond O OR dash ester, and this is anhydride, acid anhydride, and this is acetaldehyde, and this is benzaldehyde, CHO attached to benzene, aldehyde attached to benzene, and this compound is vanillin, and this is salicylaldehyde, and this one is CH double bond CH, CHO is cinnamaldehyde, and C double bond O CH3 is acetophenone, and this is propiophenone, and this compound is benzaldehyde, and this is acetone, and this is propiophenone. The next topic is preparation of aldehyde. First of all, how do you prepare aldehydes? The first step is from acyl chloride or acid chloride. When benzoyl chloride, this is the structure of benzoyl chloride, reacts in the presence of H2 and palladium barium sulfate catalyst, it forms benzaldehyde, and this is called Rosenmund reaction. From nitriles and esters, and RCN, that RCN is a nitrile, reacts with stannous chloride and HCl. It gives imine, that is RCHNH, and in presence of H3O minus, that is hydronium ion, gives RCHO with an aldehyde, and this is called Stiffened reduction reaction. And then you can also consider this in this way, that is, when nitrile react in the presence of water and aluminum hydride, isobutyl aluminum hydride twice, it gives aldehyde. And then the reaction is this, nitrile same reacts in the presence of same reagent to give this compound. Next reaction is this, in the presence of DiBlH, that is diisobutyl aluminum hydride, in the presence of water, gives this compound. All of them are same, only the steps are different. Next is Itard reaction. In Itard reaction, toluene reacts with chromyl chloride CrO2Cl2 in the presence of copper sulfate to give chromium complex. This is chromium complex, and in the presence of hydronium ion gives benzaldehyde, CHO. Next is Guttman-Koch reaction. Benzene in the presence of carbon monoxide, HCl, and anhydrous AlCl3 or copper chloride gives benzaldehyde. Next is preparation of ketones. See, first of all, ketone is prepared from acyl chloride. First we studied preparation of aldehyde, then ketones. After that, carboxylic acid. From acyl chloride, this R2RMgX plus cadmium chloride gives R2CD plus 2MgXCl, which is a Grignard reagent. MgXCl is a Grignard reagent. And 2R-C double bond OCl plus R2CD gives 2R-C double bond R and cadmium chloride. From nitriles, see, CH3 C double bond N, triple bond N, plus C6H5 MgBr in the presence of ether gives C3 CH3 CH2 CN MgBr C6H5, this big compound. In the presence of hydronium ion gives this compound, that is propiophenone. Okay, now it's from benzene or benzene substituted. Benzene, when it reacts with aryl or aryl bracket or slash R C double bond OCl in the presence of anhydrous AlCl3 gives this compound. Now this reaction is also called Friedel-Crafts acylation reaction. Now let us study something about nucleophilic addition reaction. See, what happens in nucleophilic addition reaction is that when RCN, that is cyanide, reacts with OH minus, gives cyanide minus ion plus H2O, and what is the mechanism is that it attacks the C double bond O part, which is partial positive, and this gives electron positive partial negative to form a tetrahedral intermediate, and this in the presence of H plus, this compound in the presence of H plus forms cyanohydrin. Now you see, this is the continuation part 2 of that, and the part 1 is in another page. Let me just turn that, but before that you need to know one thing. Just consider this reaction C double bond O and H2 and Z, which gives C double bond N and Z, and in this you have to consider all the compound which come under Z, and that is HROH NH2 H benzene, this, and you have to read this compound. This is, I'll read it for you. Reagent is ammonia, and carbonyl derivative is C double bond NH, and the product name is imine. This is imine. And when amine, that is a skip space, not amine, amine is not a skip space, R gives C double bond NH, and it forms substituted amine, which is also known as skip space, and OH hydroxylamine reagent is added, and C double bond N OH, that's oxime is formed, and NH2 hydrazine, C double bond N NH2 hydrazone is formed, and this compound is reagent is phenyl hydrazine. Total, the reagent is known as phenyl hydrazine, and when you add this to carbonate, it becomes like this, phenyl hydrazone, and this dineitrophenol and all of that, semicarbazide. Okay, let us turn the page now. Okay, now the continuation of this aldehyde ketones. Reduction reaction, C double bond O zinc mercury in the presence of HCl gives CH2 and H2O. This is known as Clemmensen reduction reaction, which is an important. This another reaction gives this in the presence of KOH and ethylene glycol in the presence of heat gives CH2 plus N2, which is known as Wolff-Kirschner reaction. This reaction. Next one is oxidation. CHO in the presence of oxygen, not oxygen, it is nascent oxygen, gives RCOH, and RCH2 C double bond O CH2 R dash in the presence of nascent oxygen gives RCOH plus R dash CH2 COH. Now what happens that when we cleave C1 and C2 bond plus this compound, cleavage of C2 and C3 bond takes place. This is the product formed when the cleavage takes place. Now what we need to study, the semi-topics under oxidation, is tolerance test and Fillings test. Tolerance test, RCH2 plus 2Ag NH3 twice plus 3OH minus gives RCO minus. This is also called ammonical silver nitrate solution, plus 2Ag, which is silver mirror, plus 2H2O plus 4NH3, and a silver mirror is the tolerance reagent. Now what is Fillings test? RCHO plus C2C2 plus 5OH minus gives RCO minus plus Cu2O plus 3H2O. This Cu2O is red brown precipitate. It forms red brown precipitate. And how will you remember that this forms red brown precipitate is that copper always looks red brown. So this collectively forms red brown precipitate. And aromatic aldehydes do not respond to tolerance test. Alkaline sodium potassium tetrate is also known as Rochelle salt. Let us study about oxidation of methyl ketone by Hofmann reaction. RC double bond O CH3 in the presence of NaOH gives RC double bond O ONA plus CHX3, and this compound in the presence of NaOCl forms this big compound plus CHCl3. Now let us study the preparation of preparation of carboxylic acid. First of all, it's from alkyl benzenes. That is, when this alkyl benzene, this is an alkyl group, and this benzene reacts in the presence of potassium manganese oxide KOH and heated, it forms COOK benzene, and hydronium ion forms benzoic acid. Same thing, if you react with this alkyl gives another product. Now reaction with Grignard reagent. This is the Grignard reagent, and it reacts with COCO in dry ether to give this compound. this, and it's an interesting reaction and you can remember it easily also. Now reaction with PCl5, PCl3 and SOCl2. This is the reaction. It forms these products. These are simple reaction which collectively gives simple products. Now let us turn the page and come to part 2. I hope you remember this was my notes and the continuation part was situated over here. And the last topic is halogenation. That is from Hell-Vallard-Zaleski HVZ reaction. RCH2COOH in the presence of X2 red phosphorus or red phosphorus. In presence of H2O forms as CHCOH X, where X is the halogen, any kind of halogen, and this is called alpha halocarboxylic acid. Now how do we find degree of hydrogenation? It's actually degree of hydrogenation, and it's also called DOU, degree of some other stuff. Now CA, just consider the compound CaHbXcNd and OE. If you want to find A, B, C, D and E, no, it's not if you want to find. If you want to find a degree of hydrogenation, what you need to do is that the numbers over here, just imagine these are the compounds and the numbers are represented as A, B, C, D. If it's given 12, H 13 and X 40, you have to just represent this by A, B, C, D. And now this is the formula which you need to apply to find the degree of hydrogenation. Now let us study the last but one topic, that is Canister reaction. The condition over here is no, there shouldn't be any alpha hydrogen, which you will learn in general organic chemistry. What is alpha hydrogen? This reacts in the presence of OH minus to give benzene, CO minus and CH2OH. As simple as that. Now acidity and basicity. Plus I decreases acidity, minus I increases acidity, plus I increases basicity and minus I decreases basicity. Last topic is Aldol condensation. Condition is there should be presence of alpha hydrogen. Now let me tell what is alpha hydrogen. Actually alpha hydrogen, if you consider this carbon, the hydrogen next to that is alpha hydrogen. As simple as that. Now consider this compound and this compound, which both are same, and leave this untouched, don't touch this. But what happens to this compound is that you have to just change this compound, and what happens is that the untouched compound is over here, and you just need to shift the electrons and the product becomes changed, and this untouched compound over here, you have to attack that with this compound which is changed, and you get the product which is called Aldol condensation product. Now what is cross Aldol condensation? It is the same thing, but here 2 reactants are taken, and over there 4 reactants are taken and react with each other, form different compounds. Thank you. As I always tell, you need to solve questions like this, and section B also. Thank you for watching. Answers. Thank you. Okay guys, if you like my video, do hit the bell icon and subscribe button so that you will be notified with all upcoming videos, which is fully free, and enjoy unlimited lectures. Thank you.